A stratiform deposit is essentially when you have sediment, and the sediment is very rich in sulfur. So let's take like mud and have the mud to be very, very sulfur rich. And it would have to be in an environment where the sediment and the rocks are really faulted, because the water that's way down inside the ground, which we call a brine, would have to have a lot of metals in it, like copper. And so these copper-rich brines, they move up through the faults, and when they get up, they come into contact with the very sulfur-rich mud, and what happens is the metals form ionic compounds with the sulfur, and basically mineralization occurs in little tiny layers, which we call strata, and that's the reason why it's called stratiform deposits. So in this particular diagram, you can see a lot of these little tiny greenish, brownish color stratiform deposits throughout the sediment. Here are some stratiform deposits in Newfoundland to prove its relevance. Banded iron formations is basically about a certain time in geological history. And so if we were to go back to the Precambrian, which is before 545 million years ago, there was a lot of iron in the water of our oceans and seas. However, there was no oxygen at the time because we didn't really have any species that could do photosynthesis. So we had this water that's very, very rich in iron. At some point, photosynthesizing bacteria came along, so maybe blue-green algae, stromatolites, stromatoporides, things that were able to actually do photosynthesis. And as we know, a byproduct of photosynthesis is oxygen. So for the very first time, free oxygen started to go into our world's oceans and seas, and that oxygen quickly got into compound with the iron that was in the water. And Bell Island, which is a little island in Conception Bay in Newfoundland, is basically a place where we have a lot of mines for things like hematite and magnetite. Now, hematite is a compound that's mined for iron, and so I often like to think of Bell Island as a place that we can point to prove when oxygen first arrived on our planet. And so as soon as it arrived, the iron went into compound with the oxygen and formed basically layers and layers of iron formations, which we call banded iron formations. Placer deposits is a very important one. So you always hear about people panning for gold. And so the rivers need to be meandering, which means they go back and forth. This is the case because we need the water to be basically fast in some places and slow in other places. Gold, you see, is a mineral that is very high density. The only way you can get gold to move down a river is if you have high velocity. So basically, when we look at a meandering river, and if you were to look at the diagram here, the velocity is very high on the outside of the turn and it's very low on the inside of the turn. And also you have like a vortex effect where the water kind of spins in this area. So places that you would basically get gold deposited or placed would be on these what we call point bars. So basically what I'm circling here would be a perfect place to look for gold, and here would be a perfect place for gold, and maybe even here. So you look on the point bars. You would not look here, you would not look here, you would not look here, because the velocity of the river is high and the gold would probably move on. These are just some pictures of the Klondike Gold Rush. Klondike River is in Alaska, and we know that it was a period of time where geologists were basically and prospectors were walking the Klondike River and they were panning for gold. Metamorphic deposits is the last type of deposit. So we know that when a magma moves up to the ground, the magma is so hot that it can bake the rocks that it touches. So for example, if the rock that's present in the area is limestone and limestone gets baked, we know that limestone turns to marble. Marble do have economic value, and basically we use marble for a lot of different building reasons. However, inside of magma there are fluids, and imagine if some of the fluids came out of the magma, and let's just say that those fluids were very, very rich in iron. Once those iron-rich fluids come out of the magma and goes into the marble, which is in this particular location right here, a lot of times the iron has chemical reactions with the marble and the limestone, forming these little deposits here called skarns that are very, very iron-rich. So skarns are an example of a mineral deposit that basically forms as a result of contact metamorphism. So that is basically all 10 of the different types of mineral deposits that we are going to do in this course. You need to be able to explain the formation of each one. You need to be able to identify where each mineral deposit would form in a diagram.